Hello everyone, in this video we are going to discuss the solution for punish the students. So let's study the question and then we will go and write the code. So in the question there is a professor who has just conducted a computer science paper for some students. Let's say n students. Alright. And he had instructed his students that they should sit in the roll number wise order so that he will be easily able to check those paper and he didn't have to sort the paper according to the roll number. Okay, but the students did not follow his order and sit in the random order. All right. And when he was when the professor was trying to check the papers now, he found out that none of the student listened to his advice or his order, as I might add, and rather than sitting in the roll number wise order, they sat in the random order. So the professor get frustrated and became very angry because he has to now sort all the paper in sorted order, in the roll number wise order. Okay, so he want he was very angry, so he decided that he is going to teach all the students one lesson, which was that if you don't listen to his order, then he is going to deduct your marks. Now, how he is going to deduct the marks of students? He decided to sort all the paper in the bubble sort using bubble sort. Okay, so why bubble sort? Because he is a computer science teacher. Okay, so and how do I know his computer science teacher? Because he has taken a computer science paper. So he wants to the professor has decided to sort all the paper according to roll number by bubble sort and count the number of swap required for each and every student. So for example, let's say the roll number for roll number 3, the professor need to, okay, let me write this roll number somewhere. Yeah, this is my roll number array, which is representing the order at which the paper were arranged. Roll number 3's paper come first, the roll number 2's paper were there, then roll number 4's paper, then roll number 1's paper, then roll number 5's paper. Okay, so this is the kind of order in which the papers are in currently. Okay, so what he need to do is that he needs to calculate how many times one roll number has how many times he need to swap according to bubble sort for one student so that he can deduct that many marks for one student. So let's say for example for roll number 3 the professor needed to swap a times so that his paper is in the right order. For roll number 2 he need to swap some b times. For roll number 4 he need to swap c times. For roll number 1 he need to swap d times. Roll number 5 e times. Okay, so let's say this many time of swapping he needed to arrange all this paper according to the roll number when he is using bubble sort algorithm. Okay, now he has taken this many swap for each student, each roll numbers. This is representing the roll number and this is representing the marks of the students. This is the marks for roll number 3, this is the marks for roll number 2, this is marks for roll number 4, this is marks for roll number 1, this is marks for roll number 5. So what the professor has decided to punish the student, he is going to deduct that many marks, how many times he has to sort their paper. Okay, so for example, roll number 3 got 50 marks and he needed 8 times to swap his paper to put it in the right order. So he is going to deduct that many marks. For roll number 2, he got 67 marks. So the professor needed b times swapping to arrange his paper in the right order. So he's going to deduct B marks from 67. Likewise, from roll number 4, he got 89 marks, so he's going to deduct C marks. For roll number 3, for roll number 1, he got 79 marks. He's going to deduct D marks. For roll number 5, he get 58 marks, but he's going to deduct E marks because he need to swap E times to arrange his paper in the sorted order. Okay, so this is going to give me the new marks of students. Okay, so this many marks the students are going to get. Now the professor is in some dilemma because he has to maintain some class average. Okay, and because if he don't maintain the class average, he may lose his job. So if the new average of the new marks is greater than or equal to the minimum average set by the principal or maybe the board, he has to maintain at least that many marks. So he has to maintain 68 marks average after reducing marks of every person in this order. Okay, so first we needed to calculate some new marks, and then we need to calculate new average. So let's try to make an equation and try to calculate the new average. 50 minus A plus 67 minus B plus 89 minus C plus 79 minus D plus 58 minus E and divided by the number of students. This is going to give me new average. Alright, now this equation is very difficult to read, so let's try to make it easy by putting all the numbers at one side and all the alphabet on the other side. Okay, 79, 58. Okay, so here are my numbers and here my alphabets: A plus B plus C plus D plus E. Okay, so this is how it should look, and it should be divided by n. Alright, now see carefully. Did you see something? What this numbers are representing? These numbers are representing nothing but the old marks of the students. Or rather, I should say sum of all marks, old marks. Okay, sum of old marks. And what this was representing? This was representing the number of swapping for required for one student. Roll number 3's paper should be swapped A times. Roll number 2's paper should be swapped B times. Roll number 4's paper should be swapped C times. Roll number 1's paper should be swapped D times. Roll number 5's paper should be swapped E times. So that many times the paper should be swapped. So isn't this going to give me the total number of swaps? This is nothing but total number of swap required to sort entire, not entire, but all the papers. Alright, and n is nothing but the number of student. Okay, so this is how we can calculate our new average. So let's take an example and try to count the number of swaps. Okay, let's do this. Copy this and take it down. Right. I was assuming that I have to swap A times to put roll number three's paper in the right order, B's, C, D times swapping, E times swapping, like that. Now let's try to do this ABC swapping and count actual numbers. Okay, so these are my roll numbers. Okay, now we are going to count the number of time we need to swap. Okay, if you remember the bubble sort, what were we doing in that? We were trying, we were just swapping immediate neighbors and just moving our largest number to the right. Okay, so let's start doing that. Is 3 greater than 2? Yes, we are going to swap here. So 2, 3, 4, 1, 5. Now we are going to check for 3 and 4. No, we can't do swapping here. So we move on and try to swap 4 and 1. Now 4 is greater than 1, so we are going to swap. And now we have 2, 3, 1, 4, 5. Now 4 and 5 can be swapped. No, they can't be. Oh, we were swapping and we forgot to count number of swap for each student. Remember I said each student. Okay, so 3 and 2 were swapped. Now I was swapping 3 and 2 only, but why I have tried 1 in both cases? I said I was swapping 3 and 2, and I have written that roll numbers 2's paper was swapped one time, no, roll numbers 3's paper was swapped one time. Because simply in the question we have been given that we need to count the number of swap for each and every student, for each student, which means that even in actuality we are swapping only one times, but we need to count the swapping for 2 and 3 as well, because it wouldn't be fair if I say I have swapped 3 and 2 and I am just writing that only 3's number should be increased and 2's number should not increase. But this is not the case here. We need to count swapping for 2 and 3 both. Okay, here I was swapping 4 and 1. So 1 is swapped one time, 4 is swapped one time. After this, we were trying to swap 4 and 5. Can we swap them? No, we can't. So we move further along and we now start from again. Start again. Okay. And this is my array. Can we swap? No, we can't. Can we swap? Yes, we can. 2, 1, 3, and 4, 5. Right. Now, moving on. Can we swap them? No, we can't. Can we swap them? No, we can't. Now, we have 2, 1, 3, 4, 5. Can we swap them? Yes, we can. And now we have 1, 2, 3, 4, 5. But the loop is running, so we are going to run our loop till last. Can you swap? No, we can't. Can you swap? We can't. Can you swap? We can't. So if we will count actual number of swapping, I have to add. I was swapping 3 and 1 here. So 3 and 1 was swapped here. And 2 and 1 was swapped again. Plus 1 plus 1. Total number of swapping 8. Okay. If you will count actual number of swaps, it will be 1, 2, 3, and 4. Now, the marks deducted will be 8 marks, but actual number of swap is only 4. So what we can do is, when we are trying to count the number of swap, after we have completed the count of number of swaps, we just can multiply this by 2 and we can get total marks deducted. we can get total marks deducted, we can actually find the new marks for sum of marks, and after that we can calculate a new average. And if that new average is greater than or equal to my average, or the minimum average required, is actually minimum average according to the school, college, whatever. Okay, so if this is greater than or equal to minimum average, then the professor is in the safe zone and he can actually punish those students who didn't listen to his words. So that's what he is going to do. Now, after the total number swap, we are multiplying with 2. But when we are counting number of swap, we can just add 2 instead of 1, because in both cases we are doing exactly the same thing. We can actually multiply total number of swap while doing bubble sort by 2 after we have done everything, or we can just add 2 when we are counting the swaps. So there is nothing more to that. So if we will summarize what we are doing, we have some roll number, we have been given our array of roll numbers, we have been given array of marks according to the roll number, and what we need to find is a new average of marks after deducting some marks of the students. Okay, so for this what we did was, first we tried to calculate our new marks. How we were calculating our new marks? We were just adding all the marks of the students, and then we were subtracting the number of SAPs, because we are actually calculating the average, not the deduction of marks for each student. Okay, so we did that. We were doing, first we were calculating sum of old marks, and then we were calculating number of SAP by doing the bubble sort, and then we just divided that by number of total students, and we were able to calculate our new average. Then we were comparing our new average with the minimum average, or just average of the school, that minimum average, yeah, minimum average set by the professor or the school. And if new average is greater than or equal to my set average, then students can be punished. And else, if this is not the case, if the new average is less than the minimum average, then what we are going to do, not we are going to do, the professor is going to do. Okay, so the professor can't punish them, because if he punishes them, he will be punished himself, because the principal is going to kick him out of the job, and the professor does not want that, so he won't punish the students. But if average becomes more than or equal to our new average becomes more than or equal to the minimum average, then he can absolutely punish the students. Okay, so that's all for the approach. Now let's try to code. This is very simple. First we are going to write the bubble sort and sort the roll numbers, and we are going to just count our new the number of swap for the bubble sort. After that, what we are going to do, we are calculating the sum of old marks, and then we just subtract the sum of old marks by total number of swap, and then divide by n, which is nothing but number of student. Then we are calculating new average and checking if new average is greater than or equal to average, and according to that, the professor was punishing students. So let's now code this. All right, so this is very simple. Now, what, as we discussed earlier, what we are going to do, we need to count the number of swap. So swap equals to 0. Okay, let's take n as the number of students, which will be equal to roll dot size. Okay, now we just need to do bubble sort. I hope you know the bubble sort, algorithm for bubble sort. Okay, I've already told you how we are doing the swapping and made the solution. Now I'm just writing the bubble sort here. So like this, we are done with our bubble sort. I less than n minus ITR, so that we can reduce the number of comparison. I have to write ITR. Yeah, ITR here. That's it. These are the loop for my bubble sort. Now I just need to do condition check. Roll I should be greater than roll I plus 1, which means my current element is greater than my next consecutive element. If this is the case, then I need to swap temp equals roll I and roll I equals roll I plus 1 and roll I plus 1 equals temp. That's it. We are done with the swapping. We are done with the bubble sort. Now we were counting our number of swaps. So either we can just write swap plus plus, or we can just add 2 here. If we are going to write swap plus plus here, we need to multiply the swap by 2 after we are done in the loop. Okay, so let's add 2 here and just avoid forgetting multiplying the swap by 2. Now we are done with our bubble sort. We have we have paper in the sorted order. Now what we are going to do, we are going to calculate the old marks. So old marks equals to 0, and for int I equal to 0, I less than I plus plus, because, and why n, because the number of marks will be equal to the number of roll number or the number of students. Okay, so for calculating sum of old mark plus equals marks I. That's it. Now we have the sum of old marks. Now we need to calculate the sum of new marks. So for that, in new marks equals, what was the formula? Old marks minus divided by what? Number of students. Oh no, this was the formula. Old marks minus swap. Okay, now we have the sum of new marks, and we were calculating the average by doing that. Okay, new average equals, now we need to divide by number of student. Okay, new marks divided by, let's multiply it by 1.0 first. Okay, and divided by number of student, we now have new average, and we need to check if this new average should be greater than equal to average. If this is true, then what I'm going to do, I'm going to return true, else false. Okay, well, instead of using this, I can just keep this condition only, because this is a logical operator here, and this is already going to give true or false, but I have written alternative operator so that it can be easily seen. Okay, let's run it, and we have a successful submission for input test case. So submit it, and it passed all the test cases as expected. Right, now we are done with the question. So now we need to see what are the things that we were doing. Okay, so here what we were doing just bubble sort. So bubble sort take how much time? It takes n square time, and I was calculating some old marks, how much time it takes, and time. So total time complexity for this entire should punish function should be it should be O of n square. So this should be my time complexity. Now if you will look carefully, have I used any array, stack, or recursion, or anything like that? Have I used any extra space? Okay, I have used some spaces, but this is the constant space, so my space complexity is constant. All right, so this was the solution for punish the students. Okay, so that's all for this solution for video, and I will suggest you, if you will become professor in your life, don't try to do this thing to your students. Okay, so with this is the end of video, and now I will see you in the next video with a new question. Till then, goodbye and take care.